Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Welcome to a brand new episode of the Clear to Send podcast. Glad to be here and glad to continue talking about 802.11ax. This time, we're going to talk about AX channel access, which is going to be familiar for a lot of people if you have reviewed channel access before through the previous protocols. It's going to be a little bit different in 11ax. But before we get to that, Francois, how are you doing today?
I'm very good. How are you?
I'm doing okay. It's allergy season, so my eyes are kind of puffy. Trying to keep them open, but hanging in there.
Yeah, hopefully you feel better soon.
Yeah, I'm trying to do it without. I don't have any medicine, so it's sometimes difficult, and I'm just too lazy to go get it.
So you're just curing yourself the natural way?
If by torture, sure. But yeah, we have a packed episode today, and we're going to talk about the news this week because there is quite a bit of news. The first thing is, if you guys haven't registered for Wi-Fi Tracks, which is coming up in a couple of months, you could use a special discount code that I have, which will give you, a little bit of a break on that ticket. Use the discount code RD10, so that's Romeo Delta and then a number 10, and then you'll get a discount on your Wi-Fi Trek conference. It even works on the special pricing. So right now they have special pricing. You'll get an even better discount with that code. So we'll add a link in the show notes for that, or you can head over to the CWMP website for the website itself to get registered.
And you wrote a blog article about all the good things to come at Wi-Fi Tracks. So.
Yeah. I decided to write up something since I think I've been to 2 Wi-Fi Tracks. The last one, which was in San Diego, which was a pretty good conference. I thought there's a lot of good presentations, a lot of things that I have not heard about in detail. So hopefully we get to see that same level of content from other people. I don't think I'll be presenting this year. I don't have anything ready to go, but I did present a short, a 10-minute slot on Road to CWNE. So I kind of put in that blog post that I wrote my presentation and some of the other presentations that I liked watching.
So next, Cisco has an upcoming event on April 29th, 2019. So they already shared they have a webpage ready for it. So we don't really know what date is yet, but it's something new, probably related to wireless, I would say.
Yeah, it does mention Wi-Fi 6 on there and 5G as the panel. The industry panel. So it's a live Q&A. And I don't think I've ever attended a live virtual Q&A that Cisco has done in the past, but you can sign up for it. So
that's very interesting. So live presentation with a live Q&A, keynote to present the different products, talk about Wi-Fi 6 and 5G, wired and wireless access. I mean, sounds pretty good. It's on Monday, April 29th between 10 a.m. and 11:30 a.m. Pacific time.
Yeah, I wonder what they're going to talk about. We had somebody guess that it's probably going to be something along the new Catalyst switching line. Maybe something new with their controllers. I was thinking it was going to be something about new 11ax APs, but I don't know. We'll just have to sign up and find out.
Yeah, I guess we'll see. We'll see something's coming up. I mean, 2019 is the year of
announcements.
Year of AX and Wi-Fi 6. So I wouldn't be surprised if they talk or release new Wi-Fi 6 access points.
Yeah, exactly. And And the next piece of news, because we're going to go along with these announcements here, is Niansa is announcing a brand new product, which will be tomorrow, April 16th. And what that'll be, I'm not sure, because if you guys know, have seen Niansa's presentations from Mobility Field Day, you know they have a product called Voyance, which gives you insights onto your wireless network. So this could be something completely new in regards to insight, or maybe a whole new other product that we don't know about. I don't know. Maybe they'll come out with their own 11AX piece. I'm just kidding. I don't know. I don't think they will, but it's probably more insights, more capabilities. But yeah, I'm looking forward to seeing what they have, and we'll probably see more of that maybe in the next Mobility Field Day.
So the event will be April 16th at 2 p.m. Eastern time. It's funny how some companies choose, Pacific time. Some other companies choose Eastern time.
Yeah, it's interesting because Niansa and Cisco are headquartered here on the West Coast. So
yeah, I think it's Eastern time is more like it's like in the middle between.
Yeah, it's more
Pacific
common.
and Europe,
I think.
I guess.
Yeah, you're closer towards the other guys across the pond.
Anyway, so next, Ekahau last week released a new product called Ekahau Connect. So both Roel and I are Ekahau partners, our companies, Packet 6 and Semfire Networks. We are Ekahau partners. So if you have any questions related to the new product, you can feel free to reach out to us. Or if you want to have a little demo of what the new things are looking like, we'll be happy to assist with any questions you guys have.
Yeah, if you even have questions on maybe licensing, maybe you have existing support and you want to move over to the new version, anything like that, let us know. And be sure to check out the last episode where we interviewed UC, and there was also a giveaway on that episode. So if you haven't listened to that one all the way through, only the ones who listened all the way to the end actually heard that there is a giveaway that you could sign up for. And so check that out, learn about what's new in Ekahau, and yeah, so it should be good.
Next, Meraki hits 2 million active networks. And the crazy part about it is I think they doubled in the last year.
Yeah. They've been growing like crazy. I know here in the Bay Area, a lot of companies love to use Meraki. 2 million active networks is huge. I mean, they've definitely scaled it. And they're doing that very well in terms of providing that support to their users. In terms of like new features within the dashboard, maybe there's a lot of little smaller features that I see, but nothing really big that I see coming out of the dashboard.
And they published on their website, they published a map of all the 2 million dots. So it pretty much covers the globe. And you have dots in the middle of the Atlantic and Pacific.
Yeah, the United States is just covered with Meraki. There's a lot of Meraki networks out there.
Anyway, 2 weeks ago, Intel launched a Wi-Fi 6 AX adapter. It's called the Wi-Fi 6 AX 200 adapter, and that's a chipset we could expect to see a Wi-Fi NIC we could expect to see in client devices.
Yeah, possibly newer laptops. It looks like a laptop chip. Just looking at the image of it on the website. So yeah, this will be the year of 11AX, and maybe even more so next year.
Yeah, definitely. And I believe it's a 2-stream card.
Oh, okay.
So, yeah, so, we'll
it's a
talk about
2x2,
streams,
which is interesting.
in future episodes.
Yeah, well, we haven't dove into MU-MIMO or those, but I guess we're just leaving that towards the end.
Yeah, to me it makes sense because, it doesn't draw as much power up adding more streams. So we'll talk about that, multi-user MIMO and stuff like that in future episodes. But it's a good thing that Intel is launching their Wi-Fi 6 chipset, and we should expect to see it in laptops and devices coming up next year.
Okay.
I guess this year, later on this year.
Yeah, should be exciting for new laptops. All right.
Also on April 4th, so like 10 days ago or so, Commscope completed the deal to buy Asterix, and Asterix purchased Ruckus. So now that deal is completed. We included a link if you want to know all the ins and outs and the money details about the deal. Also, we learned something about Amazon acquiring Eero. We learned that they acquired them for 97 million, which is lower than the valuation of the company, which I think was 148 million.
Yeah, that's how they actually. I think 148 million was how much they. What do they call it? Where the with the investors that they put in. That's how much they were able to raise. And Amazon bought Eero a couple of months ago, and I think this piece of news just came out recently, and I saw it as a tweet from Andrew Van Nage, and I read the article, and I thought that was really interesting, right? Because how did Amazon get such a good deal on Eero? I guess the article kind of speculated to troubles with Eero internally, I guess, but what was also interesting is seeing that the execs were able to, wipe their hands of this and leave the company with a lot of profit, and the employees don't have much anymore, right? It looked like, according to the article, that the worth of their stock that they had in Eero is worth nothing.
Yeah, that's a little sad.
Yeah, it's kind of the business here in the Bay Area, but hopefully what we'll see is Amazon integrating Eero with their product somehow, right? And I was thinking that was going to happen with their little Amazon dots or those other devices. Yeah, because you kind of put those anywhere around the house. You could turn it into mesh access points.
Yeah, that's a good idea. You need to call Jeff Bezos. Talk to him.
Pretty sure that was the idea when they purchased it. All right, and then Aruba Atmosphere just ended, and so with Aruba Atmosphere ATM, they finally put up their 11AX APs, their 500 series, the 510, 530, 550 11AX APs. They come with pretty detailed data sheets. What do you think, Francois?
Yeah, the data sheet is pretty detailed. It's awesome. Also, I like the design of it.
Yeah, I really like the look of this AP, and I've actually got to hold it at Mobility Field Day.
Oh, awesome!
Yeah, it was a nice matte
remember
finish.
the days where Aruba APs looked like smoke detectors?
Yeah, I still see those actually, in a lot of coffee shops.
They look nice. And then in the data sheet, they're talking about the new features that these access points are supporting. So you guys can go through. I think it's a nice read, especially if you are working with Aruba equipment. They do have a little asterisk when it comes to some of the features of AX, like OFDMA. It's not supported on all APs, and it will pretty much be unlocked when they upgrade the firmware.
Yeah.
So the hardware supports it, but the firmware is not there yet. So it's going to get unlocked down the road, hopefully this year. But they have some nice feature. One of them is a client match, which is pretty much the ability for the AP to steer the clients on different radios. And they're saying that they could have the capability of having one radio dedicated for AX and OFDMA, and then steer AX clients to that radio, so they will fully take advantage of OFDMA.
Yeah, I really like that idea, because what it does is they want to group similar type devices to a particular radio. And then that way you kind of maximize the potential, right, of 11AX by putting them with a radio that's only going to be servicing 11AX. I mean, you still got to deal with contention in over the air, but still having this what they're going to call an optional tri-radio mode to be able to dedicate to 11AX clients, or maybe a different radio to say 11AC clients. It's kind of interesting doing that through client match, and I'm curious how accurate and reliable that will be.
Yeah, it's very interesting. I'm curious to see how it's going to play. We had a bittersweet experience usually with those steering mechanism, but I think it's going to become more and more important in the future, especially with AX. If you fully want to take advantage of the technology, you're going to have to steer the clients to like a dedicated radio. And so we're going to have to, I guess, find ways to do it efficiently.
More in the data sheet for these APs, they really outline what is going to be supported on these APs, right? Which we don't see as much detail in some of the other data sheets. Like when I looked through this, I saw that they're going to support 37 OFDMA resource units. That's pretty cool. That's interesting because I didn't see that in, say, like a Cisco data sheet. Some of the other things, like we just mentioned, the tri-radio, they're gonna be able to support up and downlink OFDMA. So not just downlink OFDMA, they're gonna support both up and down. And there's this new to me. I don't know if this has been here before, but they have an AI-powered wireless RF and client connectivity optimization. To me, that sounds like ARM, their version of the radio management. And so I'm curious, like how AI is going to play into that algorithm, and how well will it be when it comes to making better decisions with radios, their channels, and transmit power.
Yeah. Maybe the folks that attended ATM knows more about that, but I would guess it's the AP trying to figure out the profile of the device, and depending on that, maybe doing some RF things with it. I'm not sure.
Yeah, I think once the videos are published, and hopefully they'll be public or through a login, that we'll be able to watch those videos, because that's what I'm going to be looking out for. And then one thing that I found very amusing is that the radios, the 11AX radios, are going to, with the 37 OFDMA resource units, it could support up to 1,024 associated clients per radio.
Man, we live in the future.
But the keyword there is associated. Who knows whether or not you'll get your data if you need it.
Well, with OFDM, we might be able to support more active clients, I guess, at one given time.
I'd like to test out 1,024. Yeah, I would really like to try that out. I have a use case for it. I can put it somewhere.
Yeah, something interesting I found too is when you look at the supported data rate, they support 1024 QAM on AC, which so I don't really know what that means. But that's interesting. Or maybe it's just because right after that I see a HTML tag, so maybe it's just a website issue.
Okay, but yeah, we'll include the data sheets for you guys to look over. There's a lot of info to read from the data sheet. Fully capable APs here. Looking forward to even trying these out one day. Yeah.
And also they had the little mobility field day recordings, 2 recordings during the Atmosphere conference, and it's now available on their website. So we added the link as well if you guys want to catch back and watch these videos as well.
All right. And then we wanted to highlight some reviews that people left for us. And we want to thank you guys for leaving these reviews, because it really helps us to keep going with these episodes, and also shows other potential listeners to the show, new listeners to the show, what the show is all about. And so I want to thank Ortiz3M on iTunes, M. Woodford, and Jeremy for leaving 5-star reviews on the podcast. Thank you so much.
And also we have a couple of Ikaha hats to give away, so we'll probably give them away to people leaving reviews. our faithful listeners, I guess.
Yeah. So if those three guys, if you guys are listening right now, hit me up and let me know, and I'll send you a hat. I don't have a lot of hats. Okay.
You have enough for them.
I have enough for them and a few more people. So if you do leave a review, let me know, and I'll be happy to send you a hat until I run out. And these hats came from UC and his team from our last episode. I want to thank them for giving us some swag to give away.
Yeah, thank you guys. And then the hats are very nice. Everyone loved them.
I agree.
All right, let's talk about AX.
All right.
So this week we're talking about HE channel access. So it's not like Roel said earlier at the beginning of the episodes. It's pretty much they just modified the standard, so it supports all the new features, multi-user and BSS scoring for the most part, and also they made sure that it's still backward compatible with the previous version of Wi-Fi. So that's pretty much what the HE channel access section is all about. And this section is divided in 5 different sections. And we're going to go through them, each of them, one by one, and try to explain a little bit what we understood from them.
Yeah, there are multiple functions for clients and APs to gain access to the channel. And so what we're going to talk about here are multiple things, and we'll try to cover them kind of in a summary and what we understood from the amendment. But you've got transmit opportunity duration-based RTS, CTS, intra-BSS or inter-BSS frame determination, SRG PPDU determination, 2 NAVs, MU RTS CTS, and EDCA using MU EDCA parameters. So there's quite a lot to go through, but as you have seen, RTS CTS is still here. And so, Francois, that's the good news, right?
Yeah, good news. CTS is not going anywhere.
We don't have to rename the show.
Yeah, what I wanted to say, essentially, it's, the clients and the access point will still have to access the channel and content for the channel access, pretty much the same way as we do DCF today. The only difference is we'll have a transmit opportunity for AX, and then within that transmit opportunity, you could have multi-user transmissions and all the cool stuff we talked about previously on the show.
Yeah, and it's going to leverage RTS, CTS for that transmit opportunity. So the AP can, like Francois said, use that to basically do the transmissions between your AX clients, and those exchange the transmit opportunity duration based RTS, CTS is really the AP's way of mitigating interference for like highly dense environments. And so when I see this in the amendment, I keep trying to see, okay, how is this going to play out in, say, an apartment complex in San Francisco? Like, will this be really helpful in a like mixed environment where not everyone has updated to 11AX?
Yeah, I'm not sure. And the TXOP duration-based RTS CTS, they're saying that it will only be used whenever the clients need to send for a large amount of time. Right, so if he wants to make sure that he reserves the channel for a longer time without having any problems.
Yeah, there's a threshold that would have to be met, and there is like some sort of algorithm that plays into what that threshold is.
It's a calculation.
I don't know if we want to describe that over audio.
Well, it's not that complex. They say that a client shall use the RTS CTS exchange to initiate a TXOP if the feature is enabled, obviously, and the client intend to transmit unique hash frame to the AP. or they have another like a peer client if they're using TDLS, which means tunnel direct link setup. So that's one condition, that so the client needs to be sending a unicast frame to the AP, and the transmit opportunity duration is greater or equal to 32 microseconds times the RTS CTS threshold that is set at the AP level. So the AP will set a threshold, and then you have to multiply that by 32 microseconds, and then you have to find out if your frame, your transmission will be greater than that.
Yeah. I see you like writing this formula as you're trying to describe it, Francois. I can just picture you doing that.
We have it in the show notes. So, and I even put an example in the show notes as well.
Yeah, we will. It won't be Francois writing it on a whiteboard, but it'll be close. So what's really interesting about this method, right, is it's supposed to be multi-user, and the AP sends. The AP can get simultaneous CTS responses, which is pretty cool. And then that's how it's going to basically send the frames with the RUs in it for each of those clients, which we've talked previously in some of the episodes, which is why we carefully try to be careful with how we plan out these episodes, but it all kind of ties in together in the end.
Yeah, and then just to remind you guys what the RTS CTS is all about. So pretty much in the RTS CTS, the APs and the clients, they'll just you'll have like a duration ID field, and then the AP and the clients will advertise how long they need the access to the channel for, and then advertise that to everyone, so everyone knows that they're going to require that amount of time, and everyone stay quiet during that amount of time, and so the channel is pretty much reserved, guaranteed for that transmission, and you don't have any collisions happening.
Right. And so if you're not an 11AX client, all you'll see is this a longer duration, right, for the multi-user stuff within that transmit opportunity. And so non-11AX clients are just going to use normal DCF or distributed coordinated function in order to properly handle the rules, right, and know when the medium shall be like access using the countdown.
Yeah, and then if you guys are not really familiar with DCF, there's a really good white paper from CWNP. It's called 802.11 arbitration. It's not very recent, but it's really good. It's been written by Marcus Burton, and it details how everything works. So if it could be a nice read, complementary to this episode.
Yeah, I think it's a must read for all people who want to get into wireless. It's a really good white paper.
Yeah, I agree with you.
All right, so the other channel access method, we've got intra BSS and inter BSS frame determination. Now, in a previous episode, we talked about BSS coloring, right? So when it just to kind of go back into BSS coloring is you've got a dense environment. You may have your network may be one BSS color, but another network can be a completely different color, but maybe you're on the same channel, for example. And so when a client sees that on the same channel, but you're a different BSS color, it's just gonna, I guess for lack of better words, just ignore that and then still go through its transmissions. So in order to gain access to the channel, you've got to have some way of determining, which frame is part of my BSS and which frame is an inter BSS. And so within the frames itself, there's a whole set of rules that a client goes through to determine whether it is inter or intra BSS. And then from there, it uses that as a way of getting access to the channel. And something else later on will be much more useful to this, which will be the two navs. But it is part of the channel access method in which it determines that when it can access the channel is BSS coloring is pretty important here.
Yeah, exactly. So in the section, like in the draft, if you read the section, it's just pretty much a whole bunch of rules that will help the stations to determine if the frame that it received is an intra or inter BSS frame. And essentially, in order for the transmitter to determine whether it can obtain access to the channel, to the share medium, it must determine if a receive frame is within its own BSS color or not, just to know if it has to, ignore it or take it into consideration.
Yep.
So basically, if the frame is coming from the same BSS, it will just assume that the channel is busy, and if it doesn't come from the same BSS, it will assume the channel is idle, and it will transmit on top of it.
All right. The next one, Francois and I are probably going to go more into in a future episode, but it's SRG PPDU identification, and this relates to spatial reuse. Now, I will admit, Francois and I have been putting off spatial reuse for a while because I think it's a really complex topic within the amendment and fairly hard for me to understand. And it takes a couple of reads. I remember reading through it initially, and I told you, Francois, I'm like, we got to put this off on a different episode.
Yeah, for me too. It's quite complex, and then it's also it's going to be an optional feature of AX. So it's not as important as as for us as OFDMA.
Yeah,
OFDMA. That's the one I was thinking. OFDMA or BSS coloring. But yeah, I think it will be important as well for us to go through it and try to explain what it is. And so they have something called the spatial reuse parameter set element in the frames, and so they use that as well to determine channel access, and it will be used by the client to identify if they receive inter BSS frame is a SRG frame. It's a spatial reuse frame. So it's used during spatial reuse parameter overlapping basic service set PD operations. So I guess we're going to have to explain what that is.
Yeah, we'll explain that
in a spatial reuse.
In a special spatial reuse episode. That's if we could understand the amendment.
Yeah.
So I think one of the most interesting parts to 11AX is not only do you have one nav or network allocation vector, you have two of them, right? So clients have to maintain two of those, where the AP can maintain two, but it doesn't have to. But those two navs are your intra BSS nav, and then what the amendment is now classifying as a basic nav, which is the standard nav that we're used to.
Yeah, I don't know why they called it that way. I was expecting an acronym.
Yeah, maybe a special acronym, maybe the traditional nav. I don't know. But it kind of makes sense since we have BSS coloring available in 11AX. You've got to understand channel access from two perspectives, from your own BSS and another BSS, which is your inter BSS, which the inter BSS will be classified as under the basic nav, because here we're only talking about intra BSS. You want to know when you can gain access to the channel within your own BSS color, right? And that had to do with the frame determination that we talked previously. And then anything else that doesn't cover under intra BSS, or maybe it's not able to determine if it is an inter BSS. So basically anything else, any other frame that is not classified as intra BSS or even inter BSS, it's going to fall under basic nav. And the purpose of having two navs is to protect frames from clients within the intra BSS and inter BSS in environments that could be pretty dense. And I always go back to like an apartment complex, because this is where I see a lot of Wi-Fi issues occurring, right? Everyone's on the same channel. You got a lot of contention going on. this is the high efficiency that's supposed to, I guess, solve these problems, right? Especially if these big ISPs were part of creating this amendment. And the AP itself will obtain that transmit opportunity like we discussed earlier. And basically, instead of having each of those clients contend for the channel, it's going to kind of control it for them. And that's where you have that MURTS CTS going on and transmit opportunity, and AP telling the clients, here are the RUs you're assigned, and that's when you could transmit.
Yeah, I think that's a very interesting part. The fact of having two nav, it gives more control to the AP in order to decide which clients will contend to the channel within a given TX op. Because now during one given TX op, because of multi-user MIMO, you could have multiple clients accessing the channel, and the AP will pretty much use those nav values to determine which clients will be able to talk during that given opportunity. So the AP will obtain the TX op, and then the intra-BSS nav prevents associated clients from contending for the channel. So because the basic nav is not updated during the APTX op, the client will not transmit. Even if it receives a trigger from the AP, it will see that its basic nav is not equal to 0, so it will just assume the channel is busy. So it will not reply to the AP. And then if both if both navs are equal to 0, then the medium is idle. If one of the two navs is non-zero, the virtual carrier sense just assume that the medium is busy, right?
Yeah. And that's the part that will confuse me too, because you've got BSS coloring, but then there's still this countdown in two different navs that it has to do. So it's not like they're really transmitting on top of each other.
Yeah, and then you have that, and then after that you have what happens within one given transmit opportunity. So I think it's a little confusing, but it's the goal of it. It's always to make it more efficient, right? So they try to have, I guess they try to give more control to the AP in order to achieve that efficiency, and then they try to make it work with the BSS coloring.
Yeah, you still have this duration field. We will still be familiar with that. And so when you're looking at these frames, you'll see the duration, and that's your nav, but you'll just see it in different places because you'll have your two navs.
Yeah, I think if we want to analyze this, it's going to be a little bit more work. Try to follow up the two navs and trying to understand, okay, which client is supposed to talk, and stuff like that. It's going to be more challenging for analysis.
Yeah, it will be, and you really have to understand, and this kind of is a good follow-up to the next section, which you have to understand the procedure, right, for 11AX and how channel access works, and then consider that with traditional channel access. But you have your multi-user RTS CTS procedure, because you have OFDMA, it's multi-user, multi-access. And so, like we have said before, the AP is going to get this transmit opportunity, and it's going to protect that frame exchange within that transmit opportunity. And by protect, meaning it's going to be able to coordinate these transmissions so they're not stepping on each other. And the AP will transmit this trigger frame, this MURTS CTS trigger frame, which will then receive simultaneous CTS responses from one or more clients, which I think is a really interesting concept. And there's some really good examples in the amendment of how you can see this, how you see this MURTS being sent by the AP and then sending it to specific stations, and then those stations will respond to that with a CTS response.
Yeah, so we in the show notes, if you go on the website, clearcn.net/166, you'll be able to see the diagrams of the typical packet exchange diagrams that details how that will work, multi-user RTS, CTS. So you can have a better idea of what we're talking about. So for it's pretty much the like Roald said, the multi-user RTS, the station will send so the AP will send the multi-user RTS and expect to receive a CTS from one or multiple clients.
I mean, the cool part is having it receive multiple CTS responses in order for it to coordinate that transmit opportunity and set the actual frequencies that those clients can all transmit at the same time within a given channel.
And then in the draft, they detail the rules of that, and they say, if you send a multi-user RTS but you don't receive any CTS, you just assume that it didn't work.
But importantly,
that's like the basic rule.
Yeah, but importantly, it invokes the back-off procedure, which kind of to me sounds like there was almost like a collision, because we use back-off as part of the previous protocols to talk about a collision and having to back off and do a random timer.
Well, but the random back off is used to minimize, I guess, the chances of having collisions. So, and then after that, the clients will send the CTS responses, and then once again they have the rules defined. So the client shall respond to the RTS if the following conditions are met. So the medium is idle, obviously. So it's going to check if the medium is idle using the typical carrier sense procedures we know. And then the RU allocation is specified in the user info field. So when the access point sends the multi-user RTS, it will have to specify the user info, include this user info field, and then within the user info field specify the RU allocation for all the client stations, so the client stations knows which RU to use.
Yeah, that's really neat.
And they can all reply at the same time.
Yep, on the same channel width.
On the same channel, yeah, just different RUs.
Using sub channels.
baby channels.
Baby channels.
Yeah. Something I found interesting is that they said the data rate used should be 6 megabits per second for the CTS. So, I think it's pretty cool. That's not something you see often when you read the standard. They give like data rates of frames, but
yeah, because they don't really specify data rates that often in terms of what type of frame is gonna use what kind of data rate.
And the purpose of this is just saying that they just want the CTS to be understood by everyone, right?
Yeah, which makes sense.
So everyone will know, like even non-AX stations will know that the medium will be busy.
All right,
and also it should be transmitted on the 20 megahertz wide channel, and that the channel is also specified in the RU allocation subfield, sent in the multi-user RTS trigger frame.
Yeah, so that's going to be the primary channel, especially if you're doing channel bonding, right? That's how I read it, was that 20 megahertz wide channel specified in the RU allocation subfield is really the primary channel. It's my assumption. All right. Our last section. So we all know QoS has been part of channel access. It's not going away with 11AX. Just because there's high efficiency doesn't mean we don't need QoS anymore.
Yeah, exactly. So you still have EDC operations, but they I guess they adapted it to multi-user communication. So now they're gonna have this new multi-user EDCA parameter set element, which will include details about how to do the multi-user EDCA EDCA, I guess, in a multi-user environment. So the element will be sent in beacon frames, probe responses, and reassociation frames. Yeah.
And it's interesting because I think this makes it even more complex, because within everything that we discussed, the client will then now use these parameters to set its contention windows and the MU EDCA timer. So there's even more to consider when it comes to channel access and transmit opportunity, and so much to consider with in regards to what's going on over the air. And I think it makes it even more complex for us to even troubleshoot. But I guess as long as we still understand where all these fields are and how it's all being coordinated, then maybe we can still be able to troubleshoot it. But seeing all this high efficiency looks like it's just adding a lot more complexity, right? There's a lot to it under the hood than just saying high efficiency. There's a lot to make it efficient.
Yeah, exactly. Yes, a lot of things are changing even in the communications. We talked about subcarriers on one episode. We talked about the different, symbol duration. We talked about different things that are changing. This will impact also the data rate. The data rate will be changing for OFDMA or even OFDM on the for AX. So that has a lot of impact. Bringing more efficiency will impact a lot of behind how it works really in detail. So yeah, for sure, it's gonna affect, I think, the way we troubleshoot it.
All right, let's close this out.
It's a lot of details.
It's too much for me. My contention window is ending.
So we have we actually found this in the Cisco Whitepaper on AX, and we thought it would be a good closing note. So they have this paragraph where they talk about channel access for AX, and they're talking about the preamble, right? So they have a picture of the preamble, and they're pretty much saying that the preamble is also backward compatible. So they said because of the preamble level compatibility, there is no inherent need for AX devices to proceed their AX transmission by CTS to self or RTS CTS, although devices may still choose to implement and send them to protect longer PPDUs, and that's what we talked about with the TXOP RTS CTS. However, AX adds the capability of multi-user RTS CTS, which allows the access point to resolve the channel, set the nav for multiple stations simultaneously with a single multi-user RTS PPDU that is then confirmed with simultaneous CTS PPDUs from multiple stations. And this scenario overcomes the inherent inefficiency of single user RTS CTS, still prevalent in AC networks, while adding protection to AX transmission. So they're saying that they're pretty much reviving the RTS CTS in a more efficient way with AX, so AX can be backward compatible with the rest of the world.
Yeah, and if you really think about that paragraph there that Francois read off, it's really interesting how they're able to make this backwards compatible and still be able to communicate properly with the previous protocols, right? So we have your 11AC, maybe a mixed environment with 11AX. They can still contend for the medium properly using RTS CTS, but we have this more efficiency done with 11AX with the whole multi-user access stuff. So it'll be fun times once we see this in action.
It's funny because in this particular case, sure, it might introduce more efficiency, but sometimes backward compatibility makes it more complex, introduce more overhead, limits you from what you would be able to do with the technology. So it's more often than not, it's not very used. It's not a good thing. To be always backward compatible.
Yeah, at some point you just need to move forward.
Yeah, but that's just the IEEE, operates.
Yeah,
and they're sticking to it.
All right, I mean that's our episode, guys, on 11AX channel access. I hope you guys got some good information out of it. I sure did, going through this amendment. Francois and I had to read through this section. I thought it was one of the smaller sections, Francois, but still had a lot to really understand, right? I had to go back and read some other sections that were referenced here to fully understand what they were trying to say in channel access. But I think we're getting a really good understanding of how 11AX is really going to work. we're gonna get a hold of you have gotten a hold of 11AX AP, and you now have an 11AX client. You just need to get a couple hundred more clients to test it out.
To test the efficiency of it. Yeah, this section was interesting, but going through those documents, sometimes I wish they include more diagrams.
Yeah, the pictures would have helped tremendously.
Little diagrams. It would make it easier for everyone to digest. But I understand it's very difficult to create, and they're probably always changing the document, so you'll have to change the diagram too.
Yeah.
So,
all right.
But anyway. All right. Thank you, Roel.
Yeah, thank you guys. If you guys have any questions, hit us up on Twitter. Check out the show notes. cleartosend.net/166. Let us know what you think, and we'll see you guys on the next episode.
Thank you, guys. See you, Roel. Bye-bye.
Bye.